Hello and welcome to another episode of the Kielder Observatory podcast. I'm Ian Brannan, and alongside me once again is Director of Astronomy at Kielder Observatory, Dan Pye. As we're heading towards the middle of the year with the light nights, well, let's be honest, it's not exactly the best time of year for stargazing, potentially, but there are one or two things that you can look out for, and one or two things happening in the world of space in general that might catch your attention. Plus, if there is a good time to do one thing with the night sky at this time of year, it's staying up really late and trying to get a picture of the centre of the Milky Way. This is one of the things that you can definitely do. But Dan, I mean, you've been on your travels yourself. I mean, you've not been intergalactic. You have been to Japan, though. Although, I guess being in the Northern Hemisphere, the night sky, did it look fairly similar, or were there differences at that side of the world?
Yeah, there was, but I didn't really see much of it because I was in central Tokyo and Osaka and places like that. So it was as light polluted as it can possibly get. But yeah, there is some differences down there because we are at 35 degrees in Japan, in the central Japan. So much further down the globe, almost similar to what you get in the southern parts of Spain, down towards Tenerife area. So you get a little bit more of the more southern constellations. Things like at this time of year, Scorpius is a really good constellation that's coming out at this time of year. Probably my favourite constellation, actually. And it's funny because you say like now is not a good time of year to be stargazing in the UK, but if you're in Tenerife, absolutely a good time of year for stargazing because this is when the Milky Way is coming back. So you get that central core of the Milky Way rising at this time of year, those southern latitudes, and indeed Japan as well in the darker regions in Japan. And they're doing a lot, actually, to reduce light pollution in rural areas. I was quite surprised. I was stood on a train, and some of the trains, they have little television screens and they've got adverts running on them. And there was one which was by Panasonic, and it was talking about reducing light pollution using new lighting and encouraging people to change their lighting for lights which are better for light pollution, or reducing light pollution, so we can enjoy the beauty of nature in these places. So yeah, it's a good time of year for stargazing, and Japan are doing something about dark skies in areas that are not massively light polluted.
Yeah, and on the subject of light pollution, obviously there's more LED lighting around now on streets, and people might think that, well, that actually, because it's more directional, maybe that's better. But actually, in some respects, it's worse, isn't it? Because it's white light or blue light, which is sort of sparkles in your eye a little bit more than the old yellow ones did from years ago.
That's right, and the yellow ones as well were sodium lights. So in astronomy, if you were taking images of things or even just looking at things, you could apply a filter which would filter out sodium lighting. So that's something that would help us do observations, is filtering out the sodium lighting of cities nearby. We can't do that with LED light because it's broad spectrum lighting. So it's too hard to, we can't filter out. If we filter that out, we filter out the sky as well, which is not ideal. So yeah, it's a much more difficult light to combat. It is good that it is directional in some cases, but there's also a problem that cities are getting larger. The amount of LED lighting is increasing. So we might be changing them all to these LED lights, which are downward facing and better, but we're installing more of them over larger areas. So light pollution is increasingly becoming probably one of the biggest issues right now, not just for astronomy as well, but also for wildlife populations. It's had a real dramatic effect on even down to insects. How their habitats and the effects on their lives, and that of course can have a consequential impact on the ecosystem. And us as humans, we don't like light when we're sleeping at night. This is where the term lunacy derives from. If it's too light at night because the moon's out, then you would wake up and feel a bit weird the next day and start acting strange. So. So yeah, light pollution is a really big issue, and it's hard to think about ways that we can combat this en masse without it becoming either dangerous or a risk to people's security as well. So there's a fine balance to be had here, I think, somewhere, somehow.
Yeah, which is one of the things about Kielder Observatory, of course, in the Dark Sky Park there in Northumberland, and far away from any of those problems, although you can actually see the light from the likes of Newcastle in the distance a little bit on the horizon. But as far as looking straight up goes, then looking all good. Now, looking deeper into space, there is some news here about from the James Webb Space Telescope, which we've talked about a lot, about its work that it could do. And we said that before it was launched, it would be looking into parts of the universe that haven't been looked into particularly before. And one of its missions, I guess, is to find new planets and new worlds and places where there might be people living. Whether there are little green men on there or not, we're not sure. But one thing that it has found is an exoplanet, and they're calling it a super hot super Earth, 55 Cantry E, which has been located 41 light years away, which isn't actually that far as intergalactic travel. Yeah, it's just a hop and a skip, really, when you consider some of the stars, thousands or millions of light years away. 41 light years is, just taking you back to the early 80s, isn't it? So it's not that far away as a trip. But if there are any little green men on there, they must be made of asbestos, because it seems like it's quite a hot place covered in molten lava and rocks.
Oh, lovely. What a nice place to be. But, these can be places where life can start to emerge as well, provided there's the right kind of conditions, of course, for what we know. That, just to qualify that, for what we currently know, life needs a little bit of water and these building blocks in order to be able to start functioning. And here on Earth, a little bit of molten material, minerals in the right order, mixing with some water and something to catalyse the sugar processing, and then you get some life forms. So it may be that life has started to already emerge on this little hot world. The temperature is kind of relevant, because temperature, we say, it needs to be this temperature for life to survive. Well, it doesn't really, because we see life thriving in many different conditions. Hot, boiling acid conditions, and conditions whereby there's no light and no otherwise kind of characteristic stuff that you would associate with being essential for life. So here on this planet, we have these things we call extremophiles. Is it that these resilient things have started to emerge on a world like this? Who knows? But it certainly doesn't sound like a very nice place to be. What was the temperature? 4,200 degrees Fahrenheit. That's pretty hot.
Yeah, it's quite some weather forecast, isn't it? But I suppose, really, when you consider it, many planets will have started life this way. So, as you say, we could be a number of billions of years away from it being a planet inhabited by life as we know it. But in the same way, probably Earth, we know that the moon, for example, was once covered in volcanoes and volcanic lava as well. So it is perhaps how these places do form in the very early instances.
Yeah, definitely. I think so. And then they will settle themselves down eventually, unless something happens. Maybe, things like when we look at Venus. Venus is of course very, very hot. Not as hot as this world, but it's still hot, and it's got that very thick atmosphere as a result of greenhouse gases and what have you. This would be what happened if we had too many greenhouse gases. I guess we would end up with this world which would just heat up and heat up and heat up and heat up. So maybe that will settle down. By what means, I'm not sure, because I don't really know how planets' atmospheres evolve in this case. So we need a planetary scientist to tell us all about planets, and maybe we can get one in the very near future. Not that I'm planting any seeds for future podcasts, but who knows?
No, but write it down while we remember. Good idea. And another thing that's doing the rounds at the moment, at the start of May, at the time we're recording this, NASA have put out a bit of a video of what they reckon it looks like. According to a NASA supercomputer, if it's a NASA supercomputer, it's got to be pretty impressive, right? What it would look like if you were to plunge into a black hole, into the event horizon, the black hole's no point of return. What would you see? How would it go for you? Well, NASA have got a simulation on their website and on their social media, and it is a flight towards a supermassive black hole. They've got labels on there highlighting all the different things that are going to happen to you as you head into the point of no return. But I have to say, as ways to go, it does look pretty spectacular.
It does. I was watching this the other day and I found it quite therapeutic just to sit and imagine what this might be quite like. And there's also a suggestion that when you're in there, and I don't think from memory that it really talks about this in this video, but there is a suggestion that you will eventually, just as you're dissipating into this black hole, be able to watch the entire time of the universe pass by quite quickly. And the end will suddenly be there for you. And then what happens next, who knows? But that's a slightly less comfortable thought to think about, actually. That got quite depressing quite quickly there, didn't it? It went from this nice spectacle of looking at the universe to then watching it all end. Yeah,
you took us down to an uncomfortable junction there, really, of a sort of very dour and sobering situation. But yeah, it's some great effects. Really, of course, as well, this is putting into practice various parts of Einstein's general theory of relativity. It's all rendered as a 360-degree video, so you can go in there and actually you can look around. I guess if you've got one of these VR goggles or something like that, and you've got a system you can play that on, then you can really feel that you're in there. And it's quite a way to spend your Friday night, actually, to tell people that you'd rather stay at home and jump into a black hole and see what it looks like than maybe head out with them to the pub. But that is what you can now do thanks to NASA. So there is something. But it is a question we get asked a lot, isn't it? And people love to know about black holes. What will happen to black holes, as if they're a whirling pot of mystery that are ready to drag in the next nearest planet. But that's not really the case. But that said, yeah, if you go in one, there's certainly no way out.
Yeah, there's problems. Well, there's no way out in the immediate future, but there may be in the very distant future. And this is, of course, what Professor Hawking once suggested, is that the black hole will eventually evaporate. So all of that stuff that went in comes back out some point in the future. How that happens,
there was imagine that though. That's quite some quite some ejection.
Yeah, there's some weird suggestions around how this happens as well. Some people suggest that that it can replicate matter. So matter appears outside the black hole, and inside the black hole, the same matter. And the black hole goes, "Oh, hang on a second. There's a bit of mass that's been produced in the universe, which is the same as what's inside me. So I'm just going to delete this one inside me, and therefore it's irradiated some of its mass." Almost like a computer sorting out the problems of the universe, which feels really bizarre and strange concepts to talk about. And I've probably explained it in the worst possible way there, but they are very strange, interesting places, the black holes. Yeah.
NASA have also, on that note, have got a new mission as well called the Roman mission, which is actually out looking for primordial black holes. They've discovered black holes ranging from a few times the sun's mass to tens of billions of times the sun's mass. And a group of scientists predicted that NASA's new Roman space telescope could find a class of featherweight black holes. So far, these will have eluded detection, but sort of looking for some smaller ones, the baby ones that haven't come to light so far. So not just looking for planets. This new mission, this Roman mission, is going to be out there looking for a few black holes we might not have even known were there till now.
Oh, that's really interesting. I wonder how they may have formed then, because classically we kind of think about black holes as having formed from the death of really big stars, and typically that results in stellar mass black holes that are quite large. So featherweight ones. I'm be interested to find out a little bit more about how they're constructed. But then Brian Cox also talks about a different type of black hole that we've never detected before in his latest tour that he did, which focused quite heavily around black holes and also white holes. So this theory that there is an exit point of a black hole, which is a white hole, which is the reverse of a black hole. And he talks quite heavily about static black holes. Now, static black holes are black holes which are not spinning. But all of the ones that we've seen in the universe, and someone may correct me on this, but all of the ones that we've seen in the universe have been spinning. So we've never seen a static black hole. So lovely to go and see Coxie talk about black holes, but he's talking about ones which we haven't seen before. Not that I'm trying to say don't go and listen to it. So it's fine. I feel like I'm digging a hole for myself here, a black hole for myself. But maybe Roman can do that. I just imagine Roman has been this, like, I don't know, centurion looking satellite, which is looking for things with like a helmet on and a shield.
Yeah, sort of a giant kind of intergalactic Russell Crowe flying through the stellar cosmos there, looking for black holes. A new mode of transport is hopefully going to get its first mission in the coming days. It should have been up there by now, but Boeing have they're into the space industry a lot more than ever they were. They've got their first crewed space flight for their Starliner. Now, you can go on holiday on a Dreamliner, but if you want to go to the space station, you've got to go on a Starliner. But it is not a plane, of course. It is a rocket, and what's sitting on top of it is a little capsule thing that will take you to the International Space Station. They were supposed to be launching this on Bank Holiday Monday at the start of the month, but there was some safety checks there that they weren't happy with. Nothing to do with the actual capsule that carries the astronauts themselves, but something else somewhere else in the on the launch pad they weren't happy with. So they had to wait for the next available window to be able to get them to the International Space Station. They reckon that should be Friday the 10th of May, so going very, very soon, and then it'll be blasting off from Cape Canaveral, making its way to the International Space Station. But I guess for us, growing up in an era of the space shuttle, which obviously came after the Saturn V era and all that, for us it's it is big to discover now that we're getting these proper big rockets back going again. Boeing getting in on the act, that is quite a major thing for the coming 20 years or so of space flight.
Yeah, it is. It's making it a lot more accessible for a broader audience, I guess, if you like. So having these reusable craft, which is costing much less to get up there as well, is a huge benefit to our future endeavours into the universe. And Boeing have a beautiful big building just next to just next to the Kennedy Space Center Visitor Center. Actually, it's in the car park, if I remember rightly. It's just at the end of the car park. This big Boeing building at the end of the car park, where they've been assembling a lot of this stuff. So it'll be exciting to see another competitor, in this case for SpaceX's Dragon capsule. To have more options to get into space is never a bad thing, I guess, particularly for us a little bit further over towards the west over here, because we've been quite reliant since the space shuttle era on Russian endeavours to space. So now having more options across in the Western Hemisphere is quite good, I guess. Yeah, nice, interesting. It'll be interesting to see how it goes. Fingers crossed everything goes nice and swimmingly and safely, and everybody's happy. The Dreamliner is a very comfortable aeroplane to fly on, so hopefully the Starliner is equally as comfortable.
It would be a lot easier if you could just get on a plane and fly to space, wouldn't it? That would certainly make things a lot more straightforward.
Stupid atmosphere. That's the problem, isn't it? If we had no atmosphere, everything would be so much easier. No light pollution, no worrying about escape velocity as such, other than trying to get away from the gravity, I guess. But that's easier than getting through atmosphere. Maybe? I don't know. I'm working off limited knowledge of aerodynamics there, but we just won't be able to breathe.
Yeah, I was saying getting out of the atmosphere is the easy bit, isn't it? It's coming back in where things can tend to go wrong when you've got flames and fire, sparking off the wings. That could be your issue with all that kerosene on board.
Yeah, it's not ideal. Atmosphere problematic, but also a good thing as well, because of course it protects us from all the dangerous stuff that comes from the sun, and then all of those little micrometeorites and things as well. So, yeah, it's probably good. In hindsight, actually, I think there's more benefits to having the atmosphere than not having the atmosphere. So yeah, we can keep the atmosphere for now.
Well, one person that could be flying aboard the Starliner in the coming years is a Durham University graduate. Rosemary Coogan is the UK's newest astronaut. She's been chosen from the selection process at NASA. She holds 2 master's degrees from Durham, one of 6 astronauts to graduate after passing a year-long basic training programme with the European Space Agency, actually, I should say, not NASA, and becoming the UK's latest astronaut. She's going to continue her training now. Not sure when she'll be going to space as yet. She's yet to be assigned a mission, but eventually she will be assigned a mission, and she will be guaranteed to be heading to the International Space Station at some point over the next couple of years or so, because I'm not exactly sure when these are going to be going yet, when the launches are going to be. So she's got some training to complete, spacewalk training as well she's got to undergo, but in the next couple of years she will be heading to the space station, a former Durham University graduate, as an astronaut.
Yeah, sounds brilliant. I look forward to seeing the future of her career. I think it'll be really exciting.
Yeah, when she comes down, maybe she'll come on this podcast. We never know. That could be a name. But she'll be big time by then, because she'll have like 3 billion followers on Instagram with all their sensational photos she's going to take out the window, and we probably won't get close to her for 3 years, but it's usually how it goes. So let's have a look at what's happening at Kielder Observatory then over the coming weeks and months. Well, first of all, let's start by talking about what's going on in the night sky at this time of year as we head into June. As we mentioned, well, May and June, the weeks coming round quickly. What would you? I mean, we said that we are a little bit limited, but you've got the summer triangle. That's one thing to look out for, isn't it? And tell us about what else that we will be noticing in the sky at this time of year.
I think I mentioned it last month, but of course the return of the noctilucent cloud season as we get into mid-May. That's coming back, and these, just for a reminder on these, noctilucent clouds are bits of debris in our atmosphere. So whether it be, in many cases, micrometeorites or bits of dust from entering pieces of rock from space, of which we get about 4 million every single day. So every day, 4 million bits of rock are entering through Earth's atmosphere. Consequently, that stuff often is drifting around in our atmosphere for a long period of time, and as it does during the summertime, we get a collection of it around the poles, which crystallizes. These little crystals develop around them, and then they reflect sunlight in such a way at a very specific point when the sun gets to the other side of the planet that it creates these night shining clouds, which are really, really bright, really webby kind of looking, and usually viewed best between midnight to about 2 a.m. They're probably one of my favourite phenomena that we get in the sky at night, albeit that it's not really a phenomena beyond our atmosphere. We're still looking at something in our atmosphere. It is stuff that's come from beyond our atmosphere, which is contributing to the reason why we have these clouds. So keep an eye out for those coming from mid-May all the way through until August time. And then a couple of weeks time, and I started to see it actually rising really late the other night, is my favourite constellation of Scorpius. Scorpius has an amazing star in it, which you can look at through a small telescope, pair of binoculars, called Antares, which is red, and I just think it's such a beautiful star to have a look at down on the southernmost horizon. So there's my things to look out for.
Okay, and as far as planets are concerned, not usually the greatest time of year for planets, but there is a little bit of activity coming up, isn't there? Tell us about that.
Okay, so Saturn's coming back, actually, into our skies. When we get into June, we'll be getting Saturn back in the very early hours of the morning. And then as we get into July, it's coming into a more sociable time. And then as we get into August and the dark skies start to come back in mid-August, then Saturn will be in a really good position around midnight kind of time. mid-August. So at least we'll have one of the most spectacular planets to look at through a telescope returning in the skies very, very soon. And along with it as well, a little bit later on in the year, we'll have Uranus coming back. And Uranus is probably, in contrast to Saturn, the most featureless planet to look at in the night sky.
Lower your expectations, folks.
And in July as well, Mars will be rising early hours of the morning. So this is going to be some late night planet spotting, really. So July, around about 2 a.m, Mars will be getting to an altitude where you'll be able to see that coming into view. And then as we start to get into August again, we'll get Jupiter and Mars, which are getting really quite close to each other, actually. There's a small conjunction happening just there where Jupiter and Mars are very close to each other in the sky on the 10th. Around about the 10th of August. Actually, they get really almost practically on top of each other by the 15th of August. So that might be a spectacular thing to keep an eye out for in August. Around about 2 a.m. is going to be when they're starting to get to the viewable kind of altitude. And then as we start to get the sun rising at about 4 a.m, they'll start to disappear again. But that'll be a nice thing to look forward to for the summertime, I guess. Yeah.
Something there for the diary for August then. So look out for that. And looking at the events coming up then at Kielder Observatory, there are quite a few events with availability, actually, looking the coming few weeks or so. There's quite a few sold out, but there's still a bit of stuff that you can get involved in if it's your first trip, you've never been before. Introduction to Astronomy. There's availability on the 15th of May for that one. It's a 5:30 start, but it gives you a good overview of the various things that you can get involved in as far as Kielder Observatory. And then there's later sessions as well. Jewels of the Universe. Obviously, start later because obviously it's not getting dark until later at this time of year. So Jewels of the Universe, there's a few of those. Discovering New Worlds, Our Celestial Neighbourhood, Dark Cosmos, and some kids sessions as well still available, including Young Explorers, Space Kids, Searching for Aliens, and heading into June, the Rockets and More session is back as well, which is always a good one. So a good variety there, Dan, of stuff that people can get involved with.
And then the first week in June, we'll be back at the Annick Garden, delivering a talk again about aliens and life across the universe, which is hosted by me. I'll be there because any excuse to go to Annick Garden because they've got loads of plants and stuff, and I like plants. So that's on Thursday the 6th of June between 6 and 8 p.m. You can get tickets for that via the Annick Garden website if you want.
And you went all the way to Japan for some cherry blossom, and I just went to Annick and got the same at Annick Garden. So there you go.
I would argue my cherry blossom was made nicer. Yeah, and I also got to see the cherry blossom with Mount Fuji in the background, which I think was... The cherry blossom in Japan is very different to... Not that we're going to turn this into a gardening podcast, but the cherry blossom in Japan is very different to the cherry blossom that we get in the UK. I think it is definitely more fluffy. It kind of looks more cloud-like on the trees. Beautiful thing to see. If you get a chance, go and see the cherry blossom in Japan.
Well, there's maybe an idea. There's plenty of astronomy podcasts and there's plenty of gardening podcasts. But is there a gardening and astronomy podcast in the same production? Maybe we could fill that void with all this chat. So, well, look, thanks a lot, Dan, for joining us. And, of course, if you want to find out more information about any of those sessions that are taking place, then just get yourself online to the website, kielderobservatory.org. Click on the events page and full calendar comes up with all the details of the available sessions. And go on there, book yourself in, and we will see you on that night. As I say, there's early sessions, some starting at 5:30 and some others starting at midnight, actually, as you get in towards the middle of the summer. So there's lots to go at, lots to choose from. So we hope to see you very soon. And check out some of the previous episodes on this podcast as well. There's lots of different topics covered. We mentioned black holes earlier. We've got a couple of episodes focusing particularly on that. Also on volcanoes in space and on the aurora, to name a few of the topics covered in previous episodes. Available on whichever app you're listening to now. Just scroll back, like and subscribe so you don't miss any future episodes. And we'll be back with another one very soon on the Kielder Observatory podcast.